Now, let's say we introduce such things across the load itself.
Oh, okay, okay. Well, I can't add it with, I can't take this and put it here,
Yeah,
right?
yeah.
So maybe a little bit more
Yes,
different.
yes,
no?
yes,
Okay,
yes.
okay. So what we'll do, we'll
In fact, it can be in a new page also.
we'll just do it in the new page.
Yeah.
Okay.
We will introduce a series resistor.
Series resistor. Okay. And you wanted to, this is your load resistor.
Yeah.
Okay. I'll draw the diode here because
Yeah.
you, and the load is traditionally drawn all the
At
way to the right,
correct,
no?
correct,
all
correct.
the way to the end. So
Correct.
I'll draw it like that. So this is RL.
RL.
This is some R1.
Yeah.
And this is your diode.
Yeah.
And again, you're going to sweep from some 0 to 5 volts or
Yeah,
whatever it
yeah,
is, no?
yeah.
Okay. Okay. First step again, we'll do the
Ideal
same
diode.
thing, no?
Ideal
Ideal diode.
Yeah.
Okay. So for ideal diode, what will happen? So again, this is the voltage across RL is VO. And this looks similar to, so if I look at, okay, if the diode was forward biased, no, it looks similar to the other circuit. I have one voltage source, one diode, one resistor, somehow, right? Whereas when it's reverse biased, it just looks like a resistive divider.
Correct.
So it will look like, with the resistive divider, it will just follow Vs.
Yeah. So this one, do you want to sweep from -5 to +5?
That's why, correct, good idea.
Yeah.
You'll sweep from -5 to +5.
Yeah.
We'll do that.
Maybe we'll do the positive side first.
Yes, I'll just create some more space.
Yeah.
To draw.
Yeah. Yeah.
Okay. We'll do the positive side
Yeah.
first. So, let's say Vs is 0.
Yeah.
If Vs is 0, with the ideal diode, it is just forward bias, no?
Yeah.
So, output seems to be 0.
Yeah.
So, I think it will just be here at the center.
Yes.
I'll do some other color, maybe this color. It will be here. Suppose Vs is slightly higher, no? With the ideal diode. The minute, so I'll use your trick. I'll open circuit and see what the voltage is.
Yeah.
It will be positive, no?
Correct.
It's a resistive divider.
Correct.
So then what happens is that the diode will turn on.
Yes.
It will be a short circuit.
Yes.
So then
output will be 0.
0, no?
Yeah.
Oh. So for all, in fact, I keep increasing it. The diode is always
for any positive voltage, it is 0.
Perfect. So it will just be 0. Okay. Okay.
Now we will see the negative.
Now we'll see negative. Suppose I apply some small negative voltage. The diode will be reverse biased.
So as if the diode is not there.
As if the diode is not there. In fact, for any negative voltage, it will be like
correct.
that. And at that point, the voltage here will just be RL by R1 plus RL.
Exactly.
Right? So some voltage like this, shall we say?
Yeah. Yeah.
Oh, RL by R1 plus RL.
Yeah. Is the V0.
Is the V0.
Yes.
Right?
Yeah.
Okay.
Yeah.
Nice. So this is similar to your, so one side it clamps, no? In the case of the sinusoid, one side we got rid of the sinusoid, other side we had it in time. Here it is with respect to Vs.
Correct.
We are removing one side completely for positive Vs.
Yeah.
For negative Vs, we are keeping, some relationship. Very nice, very nice.
So this is some kind of characteristic, no? Input and output.
Input and output.
How it transfers to the
okay, okay. So all of these would be input-output characteristic.
Yeah.
Or some people call it transfer characteristic. I've heard some people also call it DC transfer characteristic, right? So I've heard there are several names.
Yeah.
Right? So whenever somebody says transfer characteristics, it is input to output versus input normally.
Yes.
Whereas the other kind of characteristic is time.
Correct.
It's a signal. Do you draw the signal as a function of time?
Correct. Now
We need to do with the real diode.
Yeah, either real diode or we can add a voltage source.
Oh, correct.
Well, because we have seen it's 0.7 plus VB.
Correct. So we'll just add a voltage source.
Yeah, if we know how to deal with the VB.
That's true.
Yeah.
We'll do that. I'll also copy this.
Yeah.
So that we'll at least have the access. Okay. The negative side didn't get. I'll extend it.
I think it's okay. It's not visible. We'll use some other color this time.
We'll use some other color this
Yeah.
time. I just don't want them to be confused. That's all. Okay.
Yeah.
Okay. I'll use this color.
Yeah. So we'll introduce a
Voltage
VB
source, no?
in series.
In series. I'll make the
Any one direction. Then
any one direction,
yeah.
doesn't matter, because if it's negative, we'll just know.
Correct.
Right? Okay.
Again, we'll do 0 to plus 5
We'll do 0
first.
to plus 5 first. So if input is 0, this is the ideal diode, right?
Yeah.
So if you do 0, it's a short circuit, and then the cathode is at a positive voltage.
Yeah.
Which means it must be reverse bias, no?
Correct.
Right? And actually it is reverse bias till this point hits VB. Right? So till VB it will be reverse biased. Is that correct? Or you want to include the 0.7 also in it?
Wait. So when the diode is reverse bias, there is some current flowing through R1 and RL.
Okay, correct. You have to be careful, no?
Yeah.
Very good. So then it is not just so simple.
Yeah.
Right? So what we have to be careful about is that not when you open circuit, earlier cases when you open circuited there was no current.
Yeah.
Now there is current like this, no?
Yeah.
Correct. So now we have to be careful.
So when the diode is reverse bias, we have to actually find out that node voltage.
Correct. Only then you can apply that trick.
Correct.
Right? So I'll call this some V anode.
Yeah.
Right? So that V anode voltage is actually RL by R1 plus RL. Right? So that is the one. So V anode is RL by R1 plus RL times Vs. Right? And we need to compare that to VB.
Yes.
Okay.
So when this VA reaches VB,
correct. Then the diode will turn on.
Yeah.
Correct. So till then, the output will just be this.
This.
Right?
Yeah.
Perfect. So then, okay. So till VA reaches this, the diode is off.
Yeah.
Right?
Yeah.
So we are varying Vs, no? Okay. So
you want
and
to
we
know
want to set this to VB. Correct? Till that point.
Yeah.
Right? Okay.
So we can say Vs equal to VB
into R1 plus RL by RL.
Correct.
Right? So
Correct.
till that point. Right? So VB into RL plus
R1 by RL.
Right?
Yeah.
Till that point, the output voltage will be RL by R1 plus RL, which is VA.
Yes.
Output voltage is VA actually, right?
Yes.
So this is VO.
Correct.
So shall we draw it like this? I think what slope did we use? Some steep slope we used. Maybe it is too steep here.
Yeah.
Maybe we'll just use something like this.
Yeah.
Like this.
Yeah.
This slope.
Yeah.
Till that point. Okay. And then
once we reach there, diode is turned on.
Diode is turned on.
So in fact, maybe
I'll use a different color for that. Right? Maybe better to use a different color for that portion. So this is okay. So diode is off.
Yeah.
Okay. Reverse bias. Some people also say off. Forward bias means on.
Yeah.
Right? Okay. And then diode turns on at that time.
Correct.
So that's what we wanted to use a different color. And once the diode turns on,
That
right,
voltage is fixed to
that voltage is fixed to
VB.
VB, right?
Hmm.
Okay. Which means the output voltage will be stuck at VB,
Exactly.
right?
Yeah.
Okay. So this portion will just be stuck at VB.
Yeah.
Hmm?
Yes.
Perfect. What happens when it goes negative?
Negative. We have to see.
We have to see, right? Okay. So let me move this here.
Hmm.
Now, if it goes negative, okay, so let us see. Diode is already reverse bias, no?
Hmm.
Here at input equal to 0.
Yeah.
So once a diode is reverse biased, should it not follow the same characteristic? Will it not continue like this? Because diode is reverse biased already at Vs equal to 0, right? So will it only continue to, if I keep decreasing this voltage, going more negative,
Yeah.
will it just continue like this?
Yeah. So you are going to keep VA more and more negative.
More and more negative.
When we go in the negative direction. When Vs go in the negative direction.
That's correct.
So that means it's open circuit. That
the diode is open circuit.
It has no role.
Correct. Which means it is only a resistor divider.
Yes.
Will it just go like this?
Yes.
Okay. Okay. Nice. Nice. Oh, this is an interesting circuit, right? And I'm guessing you can make it even more complicated, no? You can add a series diode, shunt diode, you can do all kinds of things with simple.
So actually, if the diode has some series resistor also,
yes,
then
it gets a little bit more complicated as well. That is true.
Because then you have two sources, Vs and Vb.
Correct.
You may have to apply superposition to find out.
Superposition to find out. That is true. Yes.
Yeah.
Correct.